Science 14, Unit B. Heat transfer technologies. Many technologies are designed to transfer or prevent the transfer of heat. On a stove, the pots are good conductors of heat. They transfer heat to the food: copper, aluminum, steel. However, the handles are insulators to prevent the transfer of heat to your hands: plastic, wood, ceramic. As the burner heats up, heat is transferred by conduction to the pot, then to the food at the bottom. If the food is a liquid, convection currents result. Warm liquid rises, cooler liquid falls, and it is heated evenly. A similar process happens with the air in an oven, but the air also heats the walls, which then radiate heat, getting rid of excess heat. Many technologies produce excess heat. Devices like car engines and computer chips produce excess heat, so they need to be cooled. Combustion of fuel inside an engine produces heat. This heat must be removed to prevent damage from overheating, getting rid of excess heat. How liquid-cooled engine systems work. The engine's cooling system contains a liquid coolant that conducts heat away from the engine. The coolant is pumped through the engine block to the radiator, a honeycomb of metal alloy. A fan and/or the motion of the vehicle forces air through the radiator. Heat is transferred to the air. Air-cooled engines have fins on the engine to allow for greater surface area over which cooling air can flow. Computer chips usually have cooling fins and/or fans. Heat is generated by electricity flowing through wires. Some computers even have liquid cooling systems, keeping things cool. Metals and liquids often feel cool to the touch because they conduct heat away from your skin. Water is especially good at cooling because it absorbs heat as it evaporates. A refrigerator uses the cooling effect of evaporation to cool down food. A liquid coolant circulates through pipes inside the fridge. Heat is transferred from the food to the liquid. The heat is transferred to the air from the food, then to the coolant from the air. The coolant evaporates as it gets warmer, cooling off the air around it. The coolant is then pumped to the compressor, where pressure is applied to make it a liquid again. Thermal energy is released into the room, and the liquid coolant is pumped back through the fridge. Air conditioners work in a similar manner.